Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on graphing trigonometric functions. Today, we will learn how to sketch the graphs of sine functions that have variables and constants. If you are ready, students, let us start the lesson. You are already familiar with these graphs of trigonometric functions. You know that the graph of y equals sine x crosses the x-axis at pi and multiples of pi and ranges from 1 to -1. What do you think will happen if we add a variable to the function? For instance, how will the graph of y equals 2 sine x appear? The graph of y equals a sine x can be obtained from the graph of y equals sine x by multiplying each value of y by a. Students, if we look at this table, we can see that the values of 2 sine theta are simply the values of sine theta multiplied by 2. Likewise, the values of 1/2 sine theta are 1/2 the values of sine theta. If we plot these points on the same graph, we get something that looks like this. Notice that each graph crosses the x-axis at the same point, because a times 0 is 0. This means that the period is not changed by the a value. The absolute value of a is called the amplitude. It indicates the maximum deviation of the graph from the x-axis. Now let us see what happens when we sketch the graph of y equals sine k times x. We will use 2 for our value of k. In this table, we see that the sine of 2x has 0 values at 0, pi over 2 and pi. This means that the graph crosses the x-axis at 0, pi over 2 and pi. It reaches its maximum value at pi over 4. and its minimum value at 3 pi over 4. If we sketch this graph and the graph of sine of x, we see that the ranges are the same, but the periods are different. Sine of 2x completes 2 cycles in the interval of 0 and 2 pi. If we add in the graph of y equals sine of x over 2, we see that this function only completes half a cycle in the interval of 0 and 2 pi. Thus, we can say that the period of y equals sine of kx is 2 pi over k. Students, please try an activity that combines what we have learned so far. Draw a graph for one cycle of the function y equals -2 times sine of 1/3 x. Indicate the amplitude and period.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Does your graph look like this one? The period of this function is 6 pi, and the amplitude is 2. For the period, we use 2 pi over 1/3, which is 6 pi. Remember, our amplitude is the absolute value of A, which in this case is 2. Since our A value is negative, we know that the values will be reflected across the x-axis. Our graph will cross the x-axis at -3 pi, 0, 3 pi, and 6 pi. Next, we will look at the effect of constants b and c in the graph of functions. Consider y equals a times sine of kx plus b in brackets plus c. We can express this function as y minus c equals a sine of k times x plus b over k. This is simply the function y equals a sine of k times x after it has been shifted -b over k units in the x direction and c units in the y direction. If b over k is less than 0, the shift in the x direction is positive, and vice versa. If c is less than 0, the shift in the y direction is negative, and vice versa. To draw the graph of y equals 3 times sine of 2x minus pi over 3 in brackets minus 2, first rewrite the equation as y plus 2 equals 3 times the sine of 2 times x minus pi over 6. Draw the graph of y equals 3 times sine of 2x and shift it by pi over 6 units in the positive x direction and 2 units in the negative y direction. Students, please draw the graph of y equals 3 times the sine of 1/2 x minus pi over 3 in brackets plus 1. Indicate the amplitude, period, and phase shift.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Please compare your answers to these. The period of this function is 4 pi. The amplitude is 3. The phase shift is negative b over k, which gives us 2 pi over 3. Now we know that 2 pi over 3 is one of our zero values. Using our period of 4 pi, we can find our other zero values at 8 pi over 3 and 14 pi over 3. We plot these points on our x-axis, but before we draw our graph, we shift the points in the positive y direction by 1. Then we can draw our graph with the amplitude of 3. Great work, students. Today we have learned how to graph the sine function with variables and constants. We have seen how the period and range are affected by different values. In our next lesson, we will study the cosine function. Until then, thank you, teacher. Thank you, students.